Hello students, this is question number 8 of IOQM 2024 and 25. The question here it says, let n be the smallest integer such that the sum of digits of n is divisible by 5 as well as sum of digits of n plus 1 is divisible by 5. Now what are the first two digits of n in a same order? So first of all, the condition mentioned over here is that 5 will divide the sum of digits of n and 5 will also divide the sum of digits of n plus 1. So let's say we are denoting s of n as the sum of digits of n, and s of n plus 1 will become sum of digits of n plus 1. Now according to the given condition that 5 is going to divide s of n and 5 is also going to divide s of n plus 1. Now let's say the number we are assuming over here, that n does not ends with a number 9. Then if the number does not ends with the number 9, in that case what will happen? Let's say the number we have taken it as 257. Now the n plus 1, so that is going to be equal to 258. Now the difference of these two numbers will come out to be equal to 1. Means if I'm going to talk about the s of n and s of n minus 1, so this is going to come out to be equal to 1. And over here, as they have mentioned that s of n and s of n minus 1, both are multiples of 5. So the right hand side, that is 1, should also be a multiple of 5. So this will become a contradiction over here. So we can say that the number n is going to end with 5. And now let's say the number we are going to take it as some x9. Now the sum of digits of n, if I'm going to see, that is going to be equal to s of x plus 9. Now s of n plus 1 over here, it will become s of x plus 1, and that is going to be equal to s of x plus 1 plus 1. Now if I'm going to take the difference of these two, then we can see that s of n minus s of n plus 1, so that is going to be equal to 8. Now again we can see a contradiction over here. Means if I'm going to take any other number that will not be equal to 9, then in that case the condition will not hold true. Therefore the number which we are going to see now again ends with 9 and 9. Now the similar way we can apply over here, that s of n is going to be equal to s of y plus 18. Similarly, s of n plus 1, this is going to be equal to s of y plus 1, and this is going to be equal to sy plus 1. Now again, if I'm going to take a difference over here, then we can see that s of n minus s of n plus 1, so that is going to be equal to 17. So again, this is not a multiple of 5. So this simply implies that the n is now going to be equal to some z99. Now the same process will keep on continue unless we are going to get 4 nines. So if I'm going to take the number over here, let's say a times of 9, 9, 9 and 9. So this number if I'm going to take, then in that case s of n will become equal to s of a plus 36, and s of n plus 1 will become equal to s of a plus 1. Now if I'm going to take the difference over here, then we can see that s of n minus of s of n plus 1, so that will become equal to 35, and this condition will satisfy over here. Now our main target is to find out what will be this a. Now to find this a, we can see that I'm going to write it over this place. Now we can see that since 5 divides n and 5 divides also s of n plus 36, then the least number that we are going to take over here, so that will come out to be equal to 4 for sum of digits of n. So if I'm going to write it in this way, then we can see the number finally which we are going to get over here, that number n is going to be equal to 4, 9, 9, 9 and 9. And we are being asked that what are the first two digits. So the first two digits is coming out to be equal to 49, and hence 49 has to be the final answer, and the same is being provided by IOQM final answer key as well.